For your next challenge, you'll work with infrared spectrum, IR spectrum in short, of proteins. The vibrations of amide bonds in proteins are key in IR spectroscopy, providing crucial insights into secondary structures. For example, beta sheets typically produce a signal at around 1633 wavelength, while alpha helices have a characteristic wavelength near 1654 wavelength. Here's something fascinating. Proteins can undergo changes in their secondary structures when they misfold, and these changes are reflected in their IR spectra. In this challenge, you are provided with a set of IR spectrum of protein with normal structures, but you don't know which spectrum belongs to which protein: insulin, hemoglobin, beta amyloid, human prion, or alpha-synuclein. The structural details of each protein. A set IR spectrum showing potential changes due to misfolding. The information in each folder will guide you, but it won't be enough on its own. You'll need to rely on your scientific knowledge, tools, and expertise to uncover the missing data and draw connections between the evidence. The box holds only a set of IR spectra from misfolded proteins, but everything else you must determine for yourselves. Each of you possesses a critical piece of information, but only through teamwork can you reconstruct the full picture. Bioengineer. You hold IR spectra references for alpha helices and beta sheets. Bioinformatician. You possess 3D protein structure data, which allows you to predict what the normal IR spectra should look like for each protein. Biomedical scientist. You have IR spectra of normal proteins, serving as a reference point. By comparing these with the misfolded spectra from the box, you can detect deviations and pinpoint structural abnormalities. Your task is to analyze a set of unlabeled spectra and determine which corresponds to which protein. Once identified, compare these spectra with the reference spectrum of a misfolded protein. Your goal is to identify two proteins that show clear signs of misfolding and changes in secondary structure. Pay close attention to shifts in secondary structure signals between the spectra. Good luck, and may your analytical skills lead you to the correct answer.